In today's lesson, we are going to learn about anything to the power of 0. Okay, and what does that equal to? And we're going to understand why it equals that by just looking at some patterns here. So just start off here. Just as a quick review, we have right here, this is, whole thing here is my power, where b is the base. The base is the number being repeatedly multiplied together. E is my exponent. E is how many times our base is being multiplied together. And then that is equal to, when we multiply all those together, that is equal to whatever my standard form is. Okay, so this is power form. All of this here is power form, where we have an exponent telling us how many times our base is being multiplied together, and my x is in standard form. So now that we have that out of the way, let's look at an example here. Or let's try and explore what it means to be 3 to the power of 0, 4 to the power of 0. So let's start off with something like 3 to the power of 5. That is equal to, well, we have my base being multiplied together 5 times. So 3 multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3. Okay? This is equal to, which is in turn equal to, as we found out before, 243. Now let's take a look at my next one, 3 to the power of 4. That is equal to 3 multiplied by 3, multiplied by 3, multiplied by 3. So here we have 3 multiplied together 4 times. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Let's take a look at my next one here. This one we're going to have 3 to the 3, which is equal to 3 multiplied by 3, multiplied by 3, which is equal to 27. 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. My next one is going to be 3 squared. That's the same as 3 multiplied by 3, which is equal to 9. Okay? Then my last one here is going to be 3 to the 1. Anything to the power of 1, well, we don't have to write 1 because it's there. Okay? It's like saying an apple. Okay? 1, 3, well, it's not being multiplied by anything. There's just a 3, so that's going to be equal to 3. All right, now, let's take a look at a pattern here. Every time I subtract an exponent, if we go from 5 to 4, that's subtracting one exponent. What are we doing here? We are essentially, if I did all of this divided by 3, we're only multiplying 4 together, so we are dividing by 3 by going down. If I go down here, we are subtracting another exponent. 81 divided by 3 is 27, so going down there, we are dividing by 3. If I go down here again, we're subtracting 1, right? My exponent's going down by 1. To go from 27 to 29, must divide by 3. Then one more time here, let's look at this. We are going down by 1. We must divide by 3. So if I look at that now, every time I go down 1, I must divide by 3. So now if I look at 3 to the power of 0, what's happening there? In this case here, I am going down 1 more. Okay? Now 3 to the power of 0, that means I must divide 3 to the 1 by 3. So what is 3 divided by 3? That's going to give me 1. Let's try another example. Let's look at 2. Okay? Let's look at 2 here. So I'm going to say 2 to the power of 6. That's the same as 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, and times 2, which is equal to 2, 4, 8, 16, 32, 64. Okay. Let's now try 2 to the power of 5. That's just 1 less 2's. I'll use brackets this time. Okay. I'm just showing different ways of multiplying here. So we have 5 2's multiplied together. That's going to equal to 32. Let's try 2 to the power of 4. So I have 4 2's multiplied together. That's going to give me 16. Let's try 2 to the power of 3. that's just going to be 8. And now we're going to go 2 squared is, which is equal to 4. And let's try just 2 to the 1 is equal to 2. Okay? All right, so once again, the same pattern here is emerging. Every time I'm going down 1 here, I am dividing by 2. From 32 to 16, how do I get from 32 to 16? I half it. I divide by 2. I subtract 1. Here, I divide by 2. Subtract 1. So every time we go down by 1, we are dividing by the base. Here, look, every time I went down by 1, I divided by 3. 3 was the base. So essentially, we would always know 2 to the power of 1. Any number to the power of 1 is the number itself. So let's look at this here. I have to divide by the base. And any base divided by the base is going to give me 1. So then 2 to the power of 0 is 1. So essentially, any number to the power of 0 is equal to 1. And that is why any number to the power of 0 is equal to 1, because we're just going to divide the base by itself, which will give me